Hello everyone. Welcome to the 5th year of the Hewlett-Packard's Lab podcast From Research to Reality. We decided to renovate our podcast a little bit, so we introduced multiple categories. We introduced first the spotlight, and this is going to be the first spotlight of the year and of the podcast altogether. We'll also introduce unsung heroes, but you'll hear more about this. Anyways, in the first installment of the podcast on the Spotlight, we have a great honor and pleasure to host Paolo Faraboschi. Hello, Paolo.
Hi, Dan. Pleased to meet you again.
Paolo is coming for the third time, but for a good reason. It's not about Paolo, it's about the topics that he researches. So Paolo, can you please introduce yourself? What is your area and a little bit about your career?
Yes, so I currently lead AI research in Hewlett-Packard Labs, which is one of the 4 or 5 labs that we have in our organization. And I've been with HP, HPE, and some of the descendants for, I guess this is going to be my 30th year anniversary. So it's an interesting milestone, I would say. Although, I worked from very different areas and very different locations, starting with building printer chips to supercomputers, and then more recently AI. So.
And how has AI changed since the last time we spoke? If I remember correctly, we spoke 3 years ago.
Oh yeah, nothing changed, of course, right? No, I mean, it's been crazy, right? And it's about 15 months ago that OpenAI introduced the first openly, widely available generative AI chatbot, ChatGPT. And this has taken the world by surprise. It's been like a complete storm. I mean, this is the first time in history where AI technology has been really exposed to hundreds and hundreds of millions of people in a form that is very consumable, because, you can ask questions and you get, new content generated as if it like a human responding with a gigantic wealth of knowledge accumulated by effectively scanning and training on pretty much everything that's available on the internet, right? So this has caused, a lot of attention in pretty much every area, from science to industry to academia to, philosophy, regulations, and things like that, which we've never seen before. So, this kind of exponential interest of AI has also caused a lot of researchers to rethink the areas that are important to study. And like everybody else, we as practitioners in the field, we have started looking at new areas.
When you and I started, it was very simple. We developed our code. We stored it in some code revision system, of which there are many. Then open source came about, so everybody was submitting. But now there's a huge community, much broader than even developers. There are all kinds of users. So how is this community, this huge community, organized?
Yeah, it's kind of interesting because, again, with this new generative AI, kind of wave of artificial intelligence, we have seen the emergence of kind of different groups of people, right? So there's the people that are building the models, call them model producers or model builders, and there's not a lot of them because it's very, very expensive and computationally intensive, and the models are growing faster than the compute capacity in the world can sustain, and so there's few of them. They also kind of broken into like closed models that are accessible through an API, and then open models, which is the community is developing and making available in an open source form. Then, the community starts to grow in kind of a broader base of people that customize this model. We call them fine-tuning. So they take a generic foundation model, like a large language model, and then specialize it for a specific task. Let's say you want to do customer support chatbot, then you specialize it with knowledge that's specific to that field. And so that's a group of people that are building AI applications and customizing models. And then there is an even broader people that are like consumers of these applications, or perhaps people that aggregate this application into something more complicated. People are talking about agent, think about a travel agent that you speak to with natural language and is able to actually book tickets, reserve planes and book hotels for you.
And At least at the bottom or the top of that pyramid that you are talking, depending what analogy you use, everyone's complaining about the cost. It's costly to build models, to develop them, to train them. So what are the AI trends? Could you not simply run all this stuff in the cloud like we used to a few years ago?
Yeah, I mean, as I mentioned, the growth of the size of these models has been exponential, right? In the sense that, typically these models are measured in number of parameters. And the complication is that the computational complexity necessary to train one of these models grows with the square of the number of parameters. This is like an empirical law that has been established. And exponential, square relationship are bad in computer science. But I'm going to give you two data points that are kind of interesting. Like you go back 2009, 2010, this was kind of the beginning of the petascale era. And if I look at the most powerful supercomputer, which had just broken the petascale boundary at the time, it was able to train about 1 million models in a week. Right? So you take the largest AI model that was available in 2010, and you run it on the largest supercomputer, you can run 1 million, you can train 1 million of these models. So at that time, yes, it was a complicated problem, but it wasn't necessarily an impossible problem to solve. Now, fast forward in 2022, 2023, you take the largest model, something like a ChatGPT or a Llama model, and you try to train it on the biggest supercomputer, like Frontier at Oak Ridge, which just broke the exascale barrier. It would take a week to train one model, right? So, I mean, just compare these two data points in these 15 years, that means that, the complexity of actually scaling AI has gone a lot faster than what the compute capacity can offer. So now, training one of these large AI models is truly a supercomputing problem that very few can afford or have the ability to address.
If we move from development of these models and training them to using these models, what are the challenges there? How can this plethora of applications and different profiles of users integrate these models into their applications?
Yeah, it depends on really what you're doing with it. I mean, it used to be that AI usages were mostly for discriminatory purposes. I mean, like classifiers. You tag images or find some properties and understanding on what images are. But now with, again, generative AI, there's a lot broader variety of uses that touch every kind of knowledge worker. And if you're a teacher, you can use generative AI to tailor a specific curriculum for you. If you're like, again, a support person, you have a chatbot that can answer questions. So it's no longer a one category. And some of these uses are more or less critical, right? I mean, again, if you're using AI to pop up a better ad in a social network, well, the unintended consequences of a bad decision are pretty small, right? I mean, you may lose a little bit of revenue or, pop a less interesting ad. If you're using, a generative AI to create content that is supposed to be precise, for example, to give instructions on how to operate machinery, then you want to be really careful to avoid what's in the field called hallucinations, which is, the AI model, because at the end of the day, it's an expert predictor, going off a tangent and, making things up because it's what's part of the training set, right? So there's a lot of, focus in the community to enhance things like explainability of these models and robustness of these models, because those are going to be very important properties when you apply them in areas that are more critical or where like humans are involved or where, life or death decisions are involved and things like that.
So when life or death decisions are made, and if something goes wrong, you want to know what went wrong.
For example, yeah.
And one of the biggest problems I heard so far is that there's no way for us to explain how has AI made this or that decision. Is that the only problem that AI has? What are the other challenges?
No, it's not. I mean, explainability is one of the dimensions of what people refer to as, a responsible and trustworthy AI, right? So responsibility and trustworthiness is a set of properties that are very important. For example, pretty much every company, ourselves included, has developed a set of AI ethics criteria and principles, depending on, particularly the flavor of an industry. And, so we're talking about AI being secure, being private, being responsible, being inclusive, and having humans in the loop, and those kind of things, right? So all of these dimensions require new tools, new methodology, potentially new laws or regulations to make sure that there are guardrails and safeguards in the application of AI. And first of all, as the most important thing is to be able to measure, because if you can't measure, you can't fix, as people used to say. And so, understanding, for example, the robustness, understanding, the amount of bias or toxicity that, is available, could be generated by, for example, the generative AI tool is very important in that respect. Right?
So you monitor, you measure, how do you enforce it? And how do regulatory entities guide us to do that? I remember your manager, Andrew Wheeler, the head of labs and advanced development in Hewlett-Packard Enterprise, went to Senate to testify. And can you elaborate on that? What's going on there?
Yeah, this is a really hot topic across the world, right? As you mentioned, the U.S. Senate held a hearing where they invited a few experts, including Andrew, including the director of Argonne National Lab, Rick Stevens, and they're trying to understand, what are the ways in which we could, again, put guardrails around that. They were also very concerned about, technological leadership from, certain parts of the world. They're also concerned about, spread of misinformation. For example, in an election year like 2024, this is going to be another really hot topic, right? For sure. Now, regulation of AI is a really challenging topic because the field is moving very fast. I remember a couple of years, actually it was last year, 2022 in June, that, at HP Discover, I was talking about that with, in an interview, and we were saying, regulations always look in the rearview mirror because they're trying to capture what AI was, and then, it's going to take another year or two before they actually turn into implementation practice. Now, imagine if someone had made regulations in 2022 and had completely missed, generative AI. The regulations and laws would have been completely useless, right? Yep. So, so it's going to be hard to actually come up with like a one solution to fix everything. Now, transparency is important, for example. I think we're advocating that the more you can look inside a model, the better it is from the point of view of at least being able to understand when something goes wrong. What data was it trained on? Was that data containing copyrighted material or material that shouldn't have been there in the first place? Because people, the web is full of passwords and keys that shouldn't be there, right? But if models trained on those, you will remember them and spit them out. So, all these things are important. So transparency would be of really high importance to be able. And so that kind of works against the closed proprietary models because you don't know what they do. And it would probably push more in favor of the open model where, kind of in the open source sense, people can open them up and look at them and scrutinize and analyze them. But, it's kind of difficult sometimes to reconcile the commercial business interest with, the openness of the model. But I think we're going to see quite a bit of changes coming up in the next couple of years. Both on the regulatory side, but also on the community side.
So you just covered regulatory side. What about the community? What is responsibility of community in this situation?
Well, again, I think that there is a big movement that I think is very important to continue pushing forward of developing open models in alternative to closed models, right? So this doesn't mean open as in free. It means that open as in Linux, right, where the operating system is open and everybody can look at it. But of course, there are plenty of companies that are creating businesses around it, right? So it's very similar in the open model community where, you can develop and train some of these large models. What's missing today is the ability to actually train some of these large models because of what we discussed a few minutes ago. It's very expensive. So even if you could potentially create an open source model with trillions of parameters, it's going to be really challenging to train it from the monetary perspective. So there are interesting communities, for example, again, something called the Trillion Parameter Consortium that was started by Argonne National Lab in the US, but it's now an international cooperation with over 100 partners that is trying to attack this problem for foundation model for science, so that you can create a collective, group of models targeting science domains that would be open and available to the science community, so they can use them to do, better weather prediction, better material, new material studies, or new drug discovery and things like that. So those are really good examples of some community efforts, I think.
And is there any new opportunity for standards? In the past, standards were used for all kinds of things, for how you connect hookup power to wireless, interoperability, etc. Is there, for example, opportunity for deciding what is ethical, what is not ethical, or some other dimensions of AI that could be adopted across the world?
Yeah, again, the standards work well when the field is kind of stable, right? Think about standards like JPEG coders or as you say, IEEE electrical standards. When kind of the maturity of the field has reached, I don't mean like completely stable, but it's kind of it makes sense to kind of qualify things in standard. Right now, this field is moving so rapidly that it's going to be challenging. It's very similar to the regulation. Now, there are institutions like NIST in the US, for example, that are creating risk management frameworks that are kind of the closest thing to standard, which is sort of a standard on how to evaluate an AI system, right? And, for the different dimensions. There may be other things that come up in again areas like copyrighted material and things like that are not necessarily standard, but they may be self-imposed regulations that kind of somehow again regulate how to treat content that is not 100% freely available, or how to treat licenses of content and things like that.
Let's dig a little bit deeper there. When you train the models, you're getting data from the web or God knows where from, and it's really derivative content, which is not entirely new, but there's a component of new as well. And there are examples with Andy Warhol and many other cases before. So how do you think this will all play out? And there's a lot of people suing each other, organizations, right, for stealing content, etc., especially the artists.
Yeah, I used to say a couple of months ago in conversation with some colleagues that AI is having his Napster day, right? If you remember back at the turn of the
Yes.
century when, Napster was one of the first companies that started doing peer-to-peer music sharing. That was basically a legal nightmare, right, at the beginning. And it took, 15 years to be able to kind of stabilize that environment and create a new legal framework so that at least some of the business transaction would flow in the right direction. At the beginning was free for all. And now, 20 years later, we have plenty of companies working in this space that have a healthy business model to do effective music sharing. So both ends had to make compromises. I think we're going to see something very similar here, right? So clearly, it's unacceptable that a generative AI system can produce a book that looks like, some content that has been absorbed, written by some famous writer who spent all their life trying to write these books, and then some generative AI tool can create something that looks and feels the same, right? Similarly in art, graphic arts, and so on and so forth. Right now, it's the litigious phase of the development where everybody's suing everybody else, as you see. But I think there's going to be a time when agreements are going to start to put in place, right? Where okay, I'm not going to prevent you from using my content, but if you derive content from my stuff, I want to know, one, that you did it, and two, what's in it for me to let you do that without suing everybody, right? And I think there's already some movement. So the large service providers starting to strike agreements with like news organizations so that they can use that similarly to like a search derivatives. This is going to be a lot more sophisticated, but in the same direction.
Very interesting. You are director of AI Lab, but you don't focus only on core AI research. You also do application of AI to many other areas. Can you tell us a little bit about what you are focused on and what your colleagues are focused on?
Yeah, our lab has like three main threads of research. Let's put it this way. First one is we're looking at a lot of the AI data side, in the sense that, as people say, data is, the fuel of AI, because, all these systems are trained, supervised or unsupervised from a gigantic piece of data. And even to do the thing we just described, to track, what is the content that contributed to the generation of something, you need to have a data pipeline with tracking, metadata, provenance information, and so on, that enables you to at least go back and figure out, where this came from, how was the decision made, and so on. So we're working on like a metadata framework, which we're contributing to open source. We have contributed to open source that helps to make those decisions. The second area, we built a pretty significant know-how in reinforcement learning, which not surprisingly is actually one of the core technology behind the development of these new models, because once you have created a model, how you actually decide what is the quality of an input uses something that's called human feedback reinforcement learning, which is basically creating a loop that increments or decrements the value associated to an output based on some agent that decides the quality of that, right? So all of that requires a lot of technology, and we use that to even evaluate the quality of machine learning models, the output, so that we can spot toxicity and so on. And the third area of research is we're actually working on forward-looking new hardware, that is addressing responsible AI and explainable AI. So we're looking at using neuromorphic analog-based computing to lower the cost and the power. This is a little further out research, but very exciting from our perspective.
I also picked up that you're working on energy.
Oh, yeah.
Which seems extremely interesting to me. Can you tell us more?
I mean, there's actually two very exciting projects that we just started, and in collaboration. We're funded by the U.S. Department of Energy, and those are around nuclear fusion. That, as you know, is really the ultimate clean energy source, right? I mean, it's a perfect energy source. There's almost no byproduct or like. It's amazing, right? And people have been talking about fusion for 50 years at this point,
yeah.
But it's getting closer now. I mean, we're talking about having the first plants on the grid, on the electrical grid by 2035. There are lots of, and so we are in two projects of using AI and machine learning for fusion. One is for the small fusion, as we call it, which is the inertial confinement fusion, where you kind of shoot a lot of lasers on something that's about the size of a pea, and you try to ignite it, right? This was the work that's been done, for example, at Livermore at National and at NIF, that about a year ago was the first project that reached ignition. So they got more energy out than the energy they put in, which is amazing science achievement. The controlling those lasers is very challenging, right? So there's an extremely complicated equation you got to solve. Running simulation for all the possible combinations is impossible. So what AI and machine learning helps is to create these multi-fidelity simulators and decide, I'm going to run a little bit of the a lot of the cheap simulator and then a little bit of the expensive simulator to help guide this, engineering control system. And it's very promising because now you can explore a much bigger space with the same amount of computational simulation power, right? So hopefully this will help us shape better shot curves so that you can get even more energy out. And the last thing I want to mention is the other project we have is actually looking at big fusion, right? So there's like the tokamak building-sized reactors where the plasma is now magnetically contained, and in that case the problem is these are multinational collaborations. It's a big data problem of collecting and exchanging data. So we're contributing to something called the Fusion Data Platform with the technology I talked about a few minutes ago, which helps create this metadata layer and the various players work together.
There's a lot of energy coming out of you as you
this
speak
is a
about
cool,
these projects. And
these
big
are cool
energy,
projects, yeah.
So I'm delighted to see that and to hear. So you've been director for the past few years. What is the most gratifying other than this great energy that I'm seeing?
Well, I mean, as you know, I come from a different background. I'm actually not claiming to be an AI expert in any form or shape. I come from system background, building, the LAW compilers and architectures, right? To me, the most exciting thing is that, I work with people that know a lot more of AI than I do, and I learn new things every day. I mean, it is pretty amazing. I had just a bunch of people from my team that went to NeurIPS, which is one of the biggest AI conference. I got some debrief, and they were just telling me about all the new development. They tried to dumb it down so that I can understand it. But it is pretty exciting because I can actually get to talk to people that are really smart in the field and learn new things every day.
You are kind of hiding a message for the early career path people in what you just said, but can you be deliberate about that message?
Well, I think it's like challenge yourself and try not to, there's the area you studied in your PhD or something like that, but look at other things as well, right? I mean, it's always kind of exciting to see how the things you've learned are sometimes applicable. Maybe if you're an assistant person or something like that to other domains, and I think challenging yourself to kind of move into new fields that may not be very familiar is I think something that everybody should try doing.
Spotlight or not spotlight, I like to end on a personal note. What do you do in your spare time other than having here or there a glass of grappa with me?
Well, yeah, that one. Well, I need to kind of make sure I burn the glass of grappa with you. So I picked up swimming again. I mean, I used to be a swimmer and in my youth and then water polo player. So after COVID, I started getting into the mood of going a couple of times at least a week. See if I can, go past the 2 miles per session, and then occasionally go pick up some water polo scrimmage in the Bay Area. There's some activity. I'm getting older, and the other folks are younger, so it's getting challenging. But I still like to go and pick a good fight when I have some time. So.
Great insights, Paolo. Thank you very much for coming over here.
Well, thanks for having me again.